Alright, well, my name is CalebFernandez, and I'm in health and physical education, and I'm going to teach you guys a little bit about the body, but especially we're going to focus on the heart. Okay, so here's a cool little tool I found, and this lesson could be, I don't know, from middle school up to high school, so you can kind of vary with it. And here we have the human body. You can change it to male or female. And today we're going to focus on organs, and with this, your students can come out and drag it around and see everything. The blue are your veins, and the red are our arteries. And you can just play with it. I think it's a really cool tool, especially for people who don't know, how everything looks underneath. See the muscles. You see all the muscles and everything. So I thought that was a cool thing. But here we go. So this is the vein, your vein systems. It's the blue, and if I could drag this. Alright, so it says the blood circulates throughout the body. As it loses blood, it becomes blue in color. The veins carry the blood back to the heart, and that's why people say that your veins are blue. And then the red are your arteries, and the arteries pump blood to your body to get fresh oxygen from the air we breathe. And then we have the heart over here, which is the main organ of the circular system. The heart is the pump, and it's the major muscle. And I have a little, not a video, but hopefully the volume's low. Where's the volume on?
It's over on the yeah.
The ventricles in turn contract and force the blood out of the heart through. The top chamber, or atrium, collects blood from the vein and then pumps it through a valve into the bottom chamber, or ventricle.
See, there it goes there.
The ventricles in turn contract and force the blood out of the heart through the valves. Valves only allow blood to flow in one direction. The wall of the heart is made up of very special muscle fibers. Heart muscles can contract and relax throughout your entire life without getting tired. The heart muscle is supplied with oxygen and food through the coronary artery. The heart muscle becomes damaged when the coronary artery is partly blocked and oxygen cannot get to it. If the damage to the muscle is great, a heart transplant may be needed.
All right. Okay, so I think for this one we need a volunteer. If anyone, whoever wants to come up, maybe a help, go ahead and you come up. And here we're gonna have a person, and then these are the part of the heart, and you have to form it into this area.
Form the heart?
Yeah.
Oh boy, here we go.
So I think you can see the shape.
Nope.
Kind of. You can't.
Right.
On the computer you can. But yeah, so this is like you're looking this way. Yeah. So
I can see the outline of the shape.
yeah, you can see the shape there.
Oh, that's close.
So the opposite side.
Yep.
Yeah.
Tell me which side.
Yeah, that's fine.
Very good.
Maybe a little bit more to the right.
There?
Yeah, probably.
Alright.
No, opposite side.
Oh, right, each.
Yeah.
Opposite, I forget.
Good.
Pulmonary, which side's that on?
It's on the left side.
My left or your left?
There. See, if you move this down a little bit more, so you can probably see better.
Oh, yeah, I can't see that out.
There you go. Now.
This. Put this right there.
Flip them. Okay. Basically, we're just moving down. Good job. So they're going to come in here, and let's see then. Real quick. Good. Alright, so you see how the part pumps? Blood comes in, gets down here, and then pumps up to the rest of your body. We have another thing, just to get to know the names. I need another volunteer, whoever would like to come. Yeah, go ahead. Okay, so again, this is like, you're looking this way. So this would be the left side of your heart, and this would be the right side of your heart. Let's see if you would, if you could take a guess.
The right each. This is the right side?
Yeah. Good, this should stay. There you go. Very good. Down. Doing good. I got one more. One on the bottom. Oh, there's two actually. Yeah, you're good. Okay. So let's see. Thank you. And let's check it. We have a few off, but it's okay, and then we'll solve it so we can see what the real answers are. Alright, so we have the right vertical and the left one at the bottom, and then we have the arterium. I can't even say that correctly. They come up here, and then the vena and the other vein are over here, and then the artery, the carotid. Alright, next I have a little video. It's really good. It shows about heart attacks and how they work. Hopefully it plays. Is there any way I can make it full screen? No. Say again?
Can you control and scroll up on your mouse at the same time?
What are you doing?
Yeah. Let's go.
Simply to keep him in the game, John's heart and lungs are working at their limit. But by doing so, they're placing him in mortal danger. Blood is being forced faster and faster through his diseased coronary arteries. Flowing at 5 times their normal speed, blood cells eddy and swirl around his plaques. Bombarded by red blood cells, one fragile plaque is under unbearable strain. Its thin membrane is ripped open. Within moments, blood cells start to clot around the rupture. Anywhere else in John's body, this clotting response might save his life. But here, in his narrow artery, the effect is quite the opposite. The clot in John's artery traps more and more passing blood cells. It grows bigger, and the flow of blood to John's heart slows down. Downstream, the heart muscle cells are in peril. Their oxygen supply is dwindling just when they need it most. His starving cells send pain signals to his brain. But John has never experienced pain from his heart before. To him, it feels just like indigestion.
Cheerio, Steve Boss Joe. That's the old man better off and go.
He has no idea that this is the start of a heart attack. The growing clot is now blocking 2/3 of his artery. John's indigestion is getting worse. He feels a vice-like pain in his left arm. His brain is confused, overloaded with the escalating pain signals coming from his heart.